Again, my name is Tianjun, and we are being presenting RAFT, which I think you guys probably heard a lot of the RAG every day, everywhere, because LLM can hallucinate or it can connect to your enterprise different documentations. So today we'll be presenting RAFT, which is the work originally delivered by me and Shashir in Berkeley, and we had a joint blog post and an open source committee with Microsoft and Meta. I'll introduce a little bit later. But this is very exciting work, and I'm very proud of this. So I think just a little bit background about myself. I'm Tianjun. I'm a Berkeley Bear Lab and Skylab PhD. I did the work including Gorilla, RAFT, and also Live Code Bench. So these are kind of the three kind of very piece of work I've been doing the last year. So today I'll be diving into RAFT. And I want to make sure before you guys know any of the concept or before you guys actually listen to me and through all the technical details, here's a key takeaway. I know this is both way, but here's a key takeaway that I want you guys to, if anything very technical doesn't make any sense, feel free to email me or this is the key takeaway I want you guys to get home, which is RAFT is a training procedure for open question. And if you are doing RAFT, you should be doing RAFT. And hopefully throughout my presentation, I can convince you, RAFT is better than RAFT. In terms both of the performance, because you fine-tune the model tends to be more reliable and more less hallucination comparing to using prompt engineering combined with the RAFT. And also RAFT is more cheap. It's much cheaper than the RAFT models. Because I think it's also because the model is going to have much smaller model size. That's I think the key two takeaways I'm getting from this work. So let me begin by a little bit. Oh, sorry, this link. So let me begin by showing a little bit how we use LLMs today. Today we use net models and chatbots. So here's one example. We're asking the LLMs how you're doing it, and the LLMs can have a conversation with you. I'm pretty good, and I want to tell you why you may need to help me with a plan. So LLMs make sure I'm happy to do that. So here up to now, everything works fine. Everything is very perfect, works perfect. But we divided this scenario. Like this occurs very frequently in your daily chat history, but there are actually two scenarios we want to distinguish in this scenario. One is called question within LLM's training data. So in traditional machine learning field, we call this e-domain generalization or e-domain questions. And for e-domain questions, here's one example. Where is the capital of California? And model knows it's in Sacramento. Why? Because in the pre-training large corpus of the website and web data and also textbook data, the model reads a lot of the Wikipedia pages. The model already knows a lot of text where the capital of California is Sacramento from Wikipedia from different textbooks. So that it is pre-training and fine-tuning proper. It knows its information. And it can answer this information according to its own knowledge. So that's works fine. There's no problem with this. But the question occurs when you try to do some out-of-the-way question. For example, here I'm having the example, which is I'm from the Skylab, and we have the Sky retreat for every half a year. And here the question is, if you find me the timeline or the standard or the agenda of the Sky retreat. And the model now is like, I don't have any knowledge of this, and I only have knowledge until 2023. So this is a question outside the model is trained to me because the model hasn't been trained on this kind of knowledge. And but we often use it a lot because we want this to happen with my, for example, maybe personal laptops, photo data, my personal information, my lab's information. Well, it's very timely use. Like everything happened after the training proper of the language models. I want the language models to be answered to that. This also connects to a lot of personalization of model and also connects to the enterprise databases. that if you want model to be able to answer your questions here. So here's the problem we presented, and people have been really clever at delivering the techniques called the retriever augmented generation, which is RAFT. RAFT is like actually an old concept developed in 2020. There's a paper from Meta and being accepted in Europe. This paper has 2,000 more citations. So when people do this, the solution is actually really trivial and simple. It's also like our RAFT solution, which I'm going to present later. But this solution is very simple. What it always does is just to do a little bit more of Google search. For example, here, depending on my question, I can search on the website. And here I can actually find this kind of agenda appeared on the Skylab retrieve agenda. So the solution is we put all this information into the context, into the prompt. So the model knows here is a question, here is a related context that can help me answer the question. Now the model don't need to actually answer the question based on its own memory or based on its own like memorized effort during the training purpose, but the model can actually read about this context and extract information from this. This is another very important capability of the model that we want in order to connect this to some personal database or to some enterprise and timely use, for example. And now the model can answer my question very accurately because we provided a related context. So I'll be taking an analogy here to develop this open book exam, for example. So this open book is, so I think, sorry, let me take a step back. Here I want to draw an analogy here, which is RAT is basically similar to as a student, I'm attending this open book exam. But with one concept in mind, like you haven't been prepared, you haven't studied at all for the exam. This is because like maybe as a college student, you play too hard, you party too much. But the concept here is keep in mind, I'm going to explain later, but your model hasn't been prepared, hasn't been trained for this open book exam. But now the model can actually be okay on some questions as we expected. Because now you can actually read the textbooks, you can search online, you can do a lot of things to help you find the answer to your question. So even though you're not prepared, you don't know anything about the exam, like agenda, you will be doing okay in some cases. So, but the question we want to, from my personal experience and from some of the observations, if as a student we're going to prepare for the exam, we're going to do much better than in the exam, even if the exam is open book exam. I don't need to spend a lot of time trying to index which paragraph of the book is helping me answering the questions. I don't have to spend a lot of time looking up online on different sources because I studied with that for the exam. And this has been the very common case in our daily usage. Because imagine if I'm using GPT or using any language model to help me answer the documentations within this laptop, within the Arize observer, like agenda today, for example. There's a specific domain that I want the language model to know, which is everything about today's event, or everything inside this laptop, like every documentation. It won't be very, it won't be like the super open-ended. It's usually have a fixed domain that, or a collection of documentations, or even slightly larger enterprise database that you want your model to know. And you only want the model to know this, and 95% or 99% of the time, the model is going to deliver an answer to your customer or to your question that being asked. So the question here is, given that we know, it's like we are attending the college open book exam, given that we know the concept, we know the scope, we know the domain that we are going to be tested on, can we actually do better? Can we actually try to fine-tune our language models to be better at this specific domain? So the answer is, here's a gorilla, which is a very cute animal here contemplating how we should train our LLMs to be better prepared for the open book exam. And the solution we here deliver is a fine-tuning recipe here. That is quite simple. Sorry. So that is quite simple. So RAFT is a fine-tuning recipe, including dataset generation and traditional supervised fine. And there are key concepts, which I think is very intuitive when you develop training models too. The first one is called it's called like you want to train the language model to only pay attention to the related documentation, but ignoring the unrelated documentations. What does it mean? For example, here you're asking about food events and source, and this is thinking to that paper we want to impress some people. But here are a couple of papers that is being listed. For example, attention all you need, resonant, blog, and we know that attention is all you need in the paper that is being used to answer the question. But what we want to see the language model do is to ignore all the other distracted documentations, ignore all the other irrelevant information, and only pay attention to this one. It's sort of like when you're trying to indexing over all textbooks, you want to find the most related paragraph and most related documentation to that, and ignore all the other context. So when we are constructing our training data set, usually this is a format consisting of one article documentation, a couple of distractor documentation, and the question answer pairs. So the model knows, in order to answer the question, I want to relate it to all of the provided context here, but I need to ignore a couple of them because this is not related to my question. And the second behavior we want the model to know is this is called chain of thought reasoning answer. We want the model to actually write a step-by-step solution to answer the question and reason about that after we have the related context. For example, here key concept we'll be aligning here is we first will provide in the model when you're trying to answer this, when you identify which paragraph is the most important for you to answer the question, we want to first provide a reasoning stage. Like according to the documentation, how is the step-by-step answer and solution we're going to conduct in order to reach the final answer. So this part has been really important. And secondly, we are providing the begin quote and end quote. So the quoting methodology here would provide us with a method that can greatly reduce the hallucination of the language models. For example, here we're actually directly quoting from the original paragraph, directly quoting from the original documentation. And this would greatly reduce, from our experiment, ablation, and observation, greatly reduce language models' hallucination. Because the model has to write the rest of the answer based on the fact of this quote. So this method has also been used in Anthropic in OpenAI when they're trying to reduce hallucination of their language models. And we build this data set. So this is entire process how we build this data set. First one is we try to provide the question, documentation, distracted documentation, and answer triplets. And second, when we're trying to construct the answers, the two key concepts we developed here is reasoning, quoting, and reasoning and quoting. So this helps the language model to study your actual domain and to reduce hallucination of the model. So now we are going to take a look at, actually, I may need to skip this slide, but here we are going to take a look at how good is RAFT model. Seems like I think we're a little bit running out of time, but I think this, given that we know the training recipe, entire training recipe of the model, we want to know how good is RAFT. So the RAFT model has been trained on the Llama 2 model, which at that time is the best open source model we can do, the Llama 2 7B model. And here we conduct the comparison between the Llama 2 plus RAC, which is a very, very naive methodology, which is putting all the context in the all the retrieved documentations in Llama 2's context.
And we conducted our comparison between our RAFT and Llama 2 domain-specific fine-tuning. And finally, there's a very interesting comparison, which helps you reduce the cost and compare to a much more smarter like language model called GPT-4. So let's walk through how this goes. When you very naively don't study and your Llama 2 model 7B trying to do this open book exam, your performance on the Gorilla API benchmark is about 15% and under 20% on the Hugging Face and TensorFlow scenarios. And here's a RAFT performance. So you may be so RAFT is doing really good, and you may be like surprised. Yeah, you may be surprised by why this is so good. This is all because like we have been prepared for the exam, and we know this specific domain. So here's a gap like between the unfine-tuned model and fine-tuned RAFT model that you can get on your special domain. And here is the traditional supervised learning fine-tuning agenda, which you just construct different question answer pairs to help your model study the domain. And finally, the comparison we're doing here is when you are a very super smart student, you are a very strong base model. Here's performance GPT-4 can get. So the open book exam and still no study. So we can compare the orange curve and green curve here. We can see that RAFT both outperforms GPT-4 in terms of the performance, and since it's a 7B model, it's much cheaper to run than the actual GPT-4 model. So this is a key, I think, advantage when you're trying to do RAFT. It's a simple fine-tuning method. It's more reliable, but it's much cheaper. And here is just like how we are having a joint blog post with Microsoft Meta. We have been a huge attention. Here's a Microsoft blog on this RAFT part. It's up to now the most read article in Microsoft blog. So I think I'm a little bit running out of time. I'm really sorry, but the two steps are just data set preparation using our GitHub, and then you can actually do the fine tuning. Here is AI Studio that if you don't have GPU, you can do that. And here is Llama recipes. When you have GPU, you can actually try to fine tune your own on your own RAFT model. So I think thank you everyone for attending the talk here. Hopefully I've been delivering the message of we should all try to fine tune our own RAFT model to solve our RAFT problems. And feel free to email me, or I'll be staying here afterwards to answer questions. Thank you.